setting up a double integral to compute the area inside one petal of the curve. So this is objective 3.6, and we're given the r value of r equals 4 cosine 3 theta. And so the first thing we want to do is create a theta r table to get some values so that we can graph this. And so I chose 0, pi over 6, pi over 2, and pi over 3, yeah, okay. So the reason why I chose 0, pi over 6, pi over 2, and pi over 3 is because we're going to be multiplying these theta values by 3 before we do cosine of that number. So for example, we'll be multiplying 0 by 3, and then cosine of 0 equals 1. So then we'll be multiplying that by 4. So our values here, when we do that, is going to be 4. Pi over 6 will be pi over 2, so that will be 0. Pi over 2 will be 3 pi over 2 times 4, so that will be negative 4. And then pi over 3 will just simplify to pi, and then that will be 0 as well. So,
wouldn't negative 4 actually just be 0? 3 pi halves, cosine of 3 pi halves.
Oh yeah, oops, these are switched early. Thank you, so yeah. I forgot I wrote them out of order. Thank you. So, we're making our table, or our graph. At 0, we have 4. So I came out 4 units. And then I can draw my curve, my petal. And I also know that at pi over 3, which is 60 degrees, I compute that value to be negative 4. So pi over 3 is going to be something along this line. But because I have a negative value for my r value, it's going to be across the negative y-axis. So it's going to be kind of along this axis right here. So that's where this curve's going to be. And it's still going to come down 4 units right here. So now when we set up the integral, we have a couple options that we can do. We could either do half a petal and multiply the double integral by 2, or we could do the full petal. So for me, it was easiest to do the full petal, and I chose to do my double integral for this one. So I knew that right here, this is pi over 6, and here is negative pi over 6. And so I drew my bounds from pi over 6 to negative pi over 6. And then my other bound, since we're at the origin here, the lower bound is going to be 0, and the upper bound is going to be my r value. And so cosine 3 theta is for one full petal. And then, also my r dr d theta. And then I'm going to try doing it for half a petal. Okay. For half a petal, just this part, right? So I think my lower bound would be 0 to pi over 6. And then it would still be 0 to 4 cosine 3 theta. And that's multiplied by 2, right? And then my r dr d theta is for 1/2 the petal. So either option will work.